Hi guys, welcome back. This is a project for a European Central Bank sentiment indicator. For this project, I generate two sentiment indicators using two different methods. I have a sentiment indicator here for press conferences and monetary policy releases from the European Central Bank. You can see the sentiment indicator here in dark blue over time with the refinancing rate in light blue. And what you can kind of see here is a leading relationship with the interest rate. So this is a 12-month moving average, and you can see an increase here right before the refinancing rate increases. And then a decrease as well before the refinancing rate decreases here in the early 2000s. And late 90s. Similarly, in 2003, we see an increase in the sentiment indicator, followed by an increase in the refinancing rate several periods in the future. Later on in the mid-2000s, the sentiment indicator does correspond very closely to the refinancing rate. And then in the late 2010s and early 2020s, we don't see much of a relationship here between the refinancing rate and the sentiment indicator. We'll discuss a little bit why that may be. If you look here, the ECB refinancing rate is 0. So what would explain the volatility in the sentiment of the ECB press conferences and monetary policy statements? That's a good question. But in any case, I calculate this sentiment indicator using two different methods. The first method uses a list of economic concepts from Drechsel and Aroba's paper, identifying monetary policy shocks and natural language approach. So they identified economic concepts for US Fed documents. I'm just borrowing their lists of singles, doubles, and triples for this project, just to see how it compares to the other method, here using a term frequency and inverse document frequency index. If you compare the two plots, they do look similar. It's likely that Drechsel and Aroba's concepts from Fed documents are similar to concepts from the European Central Bank press conferences and policy statements. In any case, this project uses a slightly different method. It's a method used by BBVA Research. The original idea for this project came about from BBVA Research when they generated a European Central Bank monetary policy tone index. So if you check this out, I'm going to scroll down. So this came out in April 2018, and here's some work that they did. So they calculated a 12-month moving average ECB sentiment index here, and they plotted it with the refinancing rate. I made my plots for these projects similar to figure 2.3.1 here. And while the plots generated from these projects are not identical to the work from BBVA Research, they are similar, and these projects still are works in progress. But I wanted to share some ideas I had with this. So how did BBVA calculate this ECB sentiment indicator? Let's check it out. Well, they defined a specially designed dictionary for central bank language. They also used the Lawford-MacDonald dictionary, and they used a Fed dictionary for financial stability. Now, I haven't used the Fed dictionary for financial stability, but we are using the Lawford-MacDonald dictionary here. We'll go to the methodology here quickly. One of the authors of this research, Joaquin Iglesias, in 2017, detailed the pre-processing and methodology behind the indicator in this paper. And this paper is How Do the Emerging Markets Central Bank Talk? A Big Data Approach to the Central Bank of Turkey. So let's look at this. Maybe we can get a better idea of the methodology behind the indicator. Here in section 2.1, they describe dynamic topic models. They're analyzing paragraphs of the communication reports. They clean the text, and it looks like they do lemmatize here. The words are stemmed. If we scroll down a bit, you see they use a term frequency inverse document frequency index. And here's a formula for that index. So what's involved in this? Well, it takes a term frequency index, which is the count of a given word in a document, and then it takes the number of documents that contain the word, and that's the document frequency index. And it takes those two numbers and it combines them. You can think of it as an index that gives weight to frequent words through one component, through the term frequency index component. It's the TF component here. But then the weight is reduced through the IDF component, the number of documents that contain the given word. So if you have a really frequent word that occurs often in the text, this TF component will have a high weight. But if it's also in many documents, if it's also in many press conferences, or it's in many monetary policy statements, then the weight will be reduced here for the DF component. So the aim of this is to remove very infrequent as well as very frequent words. And basically the idea is that it filters out words with low semantic content, words with very little meaning. Some examples might be a word like the. The will be in every document and it will occur frequently in the text. So that's the basis for the tf-idf index. And I made some steps here so you can follow along. Maybe you won't get lost here. So the first step here, we collect text from URLs and store them in CSV files. So I have a separate program for this. It's ECB text to CSV. We have lots of URLs for press conferences and monetary policy statements from the European Central Bank. Let me show you some of these. Here's a list of URLs from the press conferences, and each of these URLs contains the text from the press conference. And then I have another list here, and these are for the monetary policy statements. So why do I put this in a separate program? View all of these URLs one time, collect the text in CSV files, and then just import the CSV files for these other programs. Basically, you don't want to visit hundreds of URLs every time you run the program. Just run the ECB text to CSV program once, get the text from these URLs, and then you could use these programs here and not have to visit these URLs all the time. So what's the key to grabbing the text from these URLs? Let's check it out. Well, you can see I put the URLs into a list. We have two separate lists, and for each list, we're going to run for loops and visit the URLs, grab the text, and then export to CSV files. So we've used this method before in previous projects using a for loop. It's very convenient. You can collect the date from the URLs and then record the date with the text you get from the URL. And that's exactly what I do. So I have two date patterns here, and these date patterns collect the date from the URLs. The URLs contain important information. They contain the year, 2025, but then they also contain the date. You can see the date format here, like for this last one. This is from 2025. The first two digits here are for the year, the second two are for the month, and then the last two are for the day. So with regular expressions, RE here, we can collect the dates, the year, the month, and the day for these URLs and associate them with the text. And that's exactly what I do here. So I set up the for loop. I set up a try here because the URL may not work, so we have an exception here. And then I match with the date pattern that I assigned up here. If there's a match, I grab the date. If there's not a match with the date pattern up here, then the date will just be empty. And then I visit the URLs, grab the text with BeautifulSoup, and then append to results. And notice I have the date appended here as well, along with the URL. So the CSV files you get from running this will contain the date, the URL, and the text. And then I do another for loop for the second URL list. It's the same setup. All that's different is the date pattern. And then you save to CSV. The names of these CSVs will be scraped texts with dates and scraped texts with dates too. Let's go ahead and run this. All right, here's the main execution block. We're visiting all of those URLs, grabbing the date, the text, the URL itself, and putting it in results and results too. And this might take some time. Okay, that took about 8 minutes. So not so bad. And then let's export to CSV files. Very quick. Let's take a look at these. Here's scrape text with dates. You can download it if you want. I'm not going to download it here. Let's take a quick glimpse though. You'll see the date here in the first column, the URL, and then the text itself. And it looks like there are about 287 rows. Let's look at the second one. So here's the second one. You can see the date in the first column, the URL, and then the text itself. Looks like I may not have the date here. Let me download this and check this out real quick. Yeah, it looks like I didn't get the date here for this first column. I'll have to check out why I didn't get the dates here. In the CSV files that I use for these other two projects, I do have the dates in there. The dates are right here. The first two digits, 98 is for 1998, 06 is for the month, June, 09 is for the day. So something with the date pattern not getting the dates here. I'll fix this before the video comes out so that the date pattern is correct and you get the dates here. In any case, let's move on. So we're going to look at the Drechsel model first. If you checked out my previous video, I'll put it in a link at the top here. I use a lot of that code for this project. It's the replication video for identifying monetary policy shocks and natural language approach. We're going to use a lot of that code, and really the main difference is that I sum the sentiment of the economic concepts per day. So I take all of these sentiment for the economic concepts and I just sum them all for a daily indicator. And that differs from Drechsel and Aroba's work because they were more concerned with specific words and phrases with economic meaning that they could apply sentiment to and look at over time. So this is more of an aggregated approach. Here's the import block, import OS and import shut IL. They are specifically for this collab. Let's go ahead and run this. We get a nice little window here to see what Colab is doing. And then you are going to mount your Google Drive, copy files to Colab, and change the working directory. Permit access for Google. Make sure you trust Google Drive for desktop. So for this one, I create a new file in Colab and a new file in my Google Drive. It's called ECB files. So you'll want to do the same. Call it ECB files, like right here. And in that file, you're going to put those CSV files from ECB text to CSV. Scraped texts with dates and scraped texts with dates too. And they're both CSV files. You can see the CSV files in my drive as well. Let's check it out. Scraped text with dates. And we have the refinancing rate here as well. It's a CSV file. And then the Lawford McDonald dictionary, which you may be familiar with. This is available to you, so you can go ahead and select these, click and drag into your own ECB file for your Google Drive, and then you're good to go. Global constants here, these are some of the same global constants as the previous work. So these are singles, doubles, and triples. These are economic concepts as identified by Drechsel and Aroba for Fed documents. And these are lists of tuples. You can tell it's a list by the square brackets, and the tuples are in parentheses here. Tuples are immutable, so you can't change the things in the tuples, but each element in the list here is an economic concept in a tuple. Doubles have 2 words, singles have 1 word, and triples have 3 words. And then I combine all the economic concepts, and so we have a list of lists of tuples. And then I have a dictionary here for words to include, like borrowing and borrowers. This is from the Drechsel and Aroba work, so let's go ahead and run this. And then the functions block. A lot of the same functions as in the previous work. Apply inclusion-exclusion function here. Let's go ahead and run this. And then the main execution block. You can see here I load in the CSV files into 2 data frames, and then I combine the 2. So for combining data frames, use the concat function, and then I group by date and concatenate all the texts for the same date. When I do this, there's no longer a URL or index, which is fine. I basically just want the date and the text. That's what I'm mainly concerned with. But you still have that data in the CSV files. We convert the date to a datetime variable, and then we sort by the date. A little different now, I have a function that cleans the text. It's called clean text here. And then I load the master dictionary from Lawford McDonald. Let's take a look back at our outline. So for number 1 here, this is what we did for ECB text to CSV, that collab. Number 2, we're running the Drechsel Economic Concepts collab. Basically, what's key is identifying the economic concepts of importance. The sentiment you generate for those economic concepts will be from the Lawford McDonald dictionary in both cases. And we're at number 3 here. We've imported and cleaned the text in the CSV files. That's what we're going to do when we run the main execution block. I don't lematize in this case, and I explain why here. And then we're at number 4 here with the Lawford McDonald dictionary sentiment. So we're going to match the economic concepts with the sentiment. So I load in that master dictionary. It's going to be in LM lexicon. And then I generate the sentiment and put the sentiment with the dates in df all. Now we do another aggregation here because there may be many instances of the same n-gram for each date, and I just want all of the sentiment for one date. So we want the sum of adjusted sentiment by date and n-gram. I get all the unique dates and n-grams, create a full data frame with all the possible date and n-gram combinations. I think this is a good idea to create a grid first of all possible combinations of dates and n-grams. N-grams are just the economic concepts, singles, doubles, and triples. So we're creating a data frame with all possible combinations of dates and n-grams. And we do this so that we could assign a sentiment of 0 for n-grams that don't exist for certain dates. So that's in full df. I then merge full df with df all, and df all had all of our n-grams and dates. Full df was the grid of all possible combinations, and I just merged them together. I create a dictionary mapping dates and n-grams. I apply the inclusion-exclusion function. Actually, I didn't think I used the function here, but yeah, I do use it. In any case, I imagine the plot is similar if you don't use the apply inclusion-exclusion function. This looks like redundant code, but I'm actually using final adjusted sentiment here, which is using sentiment from the apply inclusion-exclusion function. So it looks redundant because we have a similar code block up here, but it's actually not. This piece of code up here with adjusted sentiment may be redundant. I'll have to go back and take a look at this, but still a work in progress in many ways. I think I did this because we had to create the full grid with the n-gram sentiment df here, and then we have to aggregate again after we merge with the grid. And then I fill in the missing values. So remember, after we merge with the full grid, we're going to have some n-grams with 0 sentiment per day. I go ahead and add the zeros in for those n-grams that aren't in every press conference or monetary policy meeting. If some words aren't included in the press conferences or policy meetings, then I give those missing observations a 1. And this is basically for the scaled sentiment. When we calculate a scaled sentiment indicator, we don't want to divide by 0 here. Scaled sentiment, if you remember, is the total sentiment divided by the total words. And then I calculate standardized sentiment. We take the scaled sentiment, we subtract the mean of the scaled sentiment, and then divide by the standard deviation of the scaled sentiment. So standardized sentiment here is our final indicator for daily sentiment, standardized sentiment. So standardized sentiment is the sentiment that we're going to use for the plots, except we need a 12-month moving average, and we're going to do that here in a second. For the plot, we want to load in the refinancing rate in that CSV file. We put that in ECB_DF. We're going to create a pivoted data frame, getting ready for that plot. Now I resample to a monthly frequency and then apply a 12-month moving average. I add another column for year, month for merging. And so we have another column here in our data frames. Why? Well, the ECB refinancing rate, it may be set up with different dates compared to the sentiment scores that we have in our data frame. So we have a little adjustment there. We drop any rows with missing data if needed. I wanted to show the correlation between the two indicators, the refinancing rate and the sentiment score. So I calculate correlation here as well. And then we have each of those indicators plotted on a y-axis. So we need a dual axis plot. We do that because there are different units for the two indicators. Refinancing rate is in percentages. The sentiment indicator is standardized sentiment, so it's going to have 0 at the center. Refinancing rate is different. So with different units, we put each indicator on its own axis. Color the axes differently. I went with a color similar to the BBVA Research file. If you check this out, the dark blue is the 12-month moving average. Light blue is the ECB refinancing rate. I used the same colors and then plotted. Let's go ahead and run this. And this might take a little bit of time, but we did a lot of the heavy work with the URLs and putting that into CSV files. So in this case, we're just importing the CSV files. We're doing some cleaning. We're generating some sentiment scores, matching with another CSV file, and then importing another CSV file with a refinancing rate. But that only took 49 seconds, so much faster than the text to CSV file. And here's the plot. I mentioned some of these hills and and valleys, it looked like there was a leading relationship with the refinancing rate. That does sort of seem to be the case, but it's not very exact. This is a 12-month moving average. We're looking at long-run trends over time. So we see these two hills here before the ECB rate rises, and then we do see sort of a confluence of the two indicators. However, we see two big hills here again before the ECB rate rises. That's kind of interesting. We had two hills here as well, and then the ECB rate rose. Similar timing, but it looks like the ECB rate rose later here in this hill than previously. Previously it was here in the center. Let's check out the other project. Maybe we get a similar plot using a different method for identifying those economic concepts. Here's the second plot. I'll show you just some of the main differences between these two approaches. So as I mentioned before, the second program uses term frequency inverse document frequency. It's a method used by the research team at BBVA. We still associate positive and negative sentiment with the law firm McDonald dictionary, and then we accumulate by date and then plot. We're using the same file, ECB files. The import block is a little different. We have this module here, and we also use NumPy. But this is our tf-idf vectorizer, and that's going to help us create that index. Go ahead and run this. Okay, all is good. Mount the Google Drive, connect, give it permissions, continue. Okay, no issues there. We have fewer global constants now. We don't have the lists that we had before. We're going to generate our own lists using the frequency of words and the frequency of documents containing the words. The functions block, I have the text cleaning all here within a function. Makes things nice and easy. Now if I need to change the function, maybe I want to lemmatize. I can include that in this function, and I might do that at a later date. Remember, we can lemmatize for this project. And we have two new functions here, define preprocess. We're going to tokenize the text for the tf-idf model. So just a little preprocessing before we do the tf-idf vectorizer. We find the words and phrases that we think are important, and then we find the top n-grams for the document. So we get the top concepts from the vectorizer, and much of the main execution block is the same. We combine the CSV files, we clean the text, but when we clean, we're going to use the preprocess function that I mentioned before. We define the vectorizer for unigrams, bigrams, and trigrams. And to create the tf-idf matrix, we're using clean text here above from the preprocess function above here. We get our feature names here from that vectorizer. We compute tf-idf scores per n-gram. Even have a print statement in here for the top 20 n-grams. You'll see these may not be economic concepts, which is kind of the downside of just using a tf-idf index and using the vectorizer in this manner. The vectorizer isn't going to know what's an economic concept or not. So a combination of both might be preferable, might be optimal. Here we use NumPy, NP, to sort the indices. We have our top n-grams here, and those are the n-grams we're going to use. We're using the top 100 n-grams only, unigrams, bigrams, or trigrams, singles, doubles, or triples. We put them in lowercase, and then we load in the master dictionary. We calculate sentiment. We group by date and n-gram. We create that full grid that I mentioned before. We scale and standardize. Much of this code is similar. And then we plot, again with similar colors. These might be identical colors to the previous plot. And here you can see the top 20 n-grams. So question, euro, inflation, growth, wood. See, if we were selecting these n-grams, similar to Drechsel and Arroba, we would probably just drop some of these like question, wood. They're too general and they don't really give us any important information. Euro area we would keep. Duesenberg, he must be someone important. Wim Duesenberg, Dutch politician and economist, president of the European Central Bank. So his name pops up often. So let's go ahead and run this, and it's done. Here's our index here. What kind of stands out here if we compare the two, we have these big swings here that we don't have with Drechsel. The swing here is much less dramatic than the swing here, the downward swing. The upward swing is similar. It goes up to 2 here on our index, and it's 2 up here for this index, but the swing downward, it goes to -1 and further, whereas this swing down goes to -0.5. The other components here are very similar. The sentiment here after that is pretty similar. So for the tf-idf model, we do have this upward sort of trend in the sentiment that you don't really see here with Drechsel and Arroba. They're single, doubles, and triples. Be careful, this isn't their work. This is using their economic concepts that they identified for Fed documents. But we do see this upward trend that's kind of interesting, but otherwise pretty similar. Like I said, these are two projects that are still works in progress. If you have some ideas here, I have a couple myself how to improve the sentiment index. I mentioned already using a combination of selection methods, the lists of singles, doubles, and triples in conjunction with the tf-idf model. I think that would produce better results. We don't need things like question or would or like say here. We could drop those. We don't really need the sentiment for those words. And then the inclusion of some words like Euro area, I think that would be useful. Another idea I had was with the tf-idf selection method, it uses weighted components to generate n-grams that are important. So if the n-grams are much too frequent or much less frequent, they're not going to be included. Well, I wonder if like a weighted scheme for the sentiment scores would be useful as well. If we have a point of comparison here with a refinancing rate, we could see which combination of sentiment scores would produce better results in terms of closer correlation to a refinancing rate. If there is a leading relationship here, maybe we could find the best relationship with the lead or lag of the sentiment. It makes sense that some ECB documents would be more important or may more closely relate to the ECB refinancing rate in comparison to other documents, or maybe at different points in time the relationship will be closer or further apart. Those are a couple ideas I have. What ideas do you have? Go ahead and leave a comment below, and if you like this, like the video and subscribe to me. That's going to be it for now, but thank you guys. Bye-bye.